Alright, today we're going to be looking at Chapter 9, Topic 1. Chapter 9 is on sequences and series. Today we are going to be looking at sequences as they relate to functions. So a sequence is a particular set of numbers in a particular pattern. Sequences can be finite, which means that they end or terminate, or they can be infinite, which means that they don't terminate, they go on forever. You can denote a term in a sequence by using the letter A with a subscript, where the subscript is the term number of the sequence, or the number of the sequence where the term is. So what that would mean is that the first term would be A with a subscript of 1, second term would be A with a subscript of 2, and etc. Now, we are going to be looking at two different types of sequences today, arithmetic and geometric. These are not the only two types of sequences, but these are the only types that we will see. Arithmetic sequences are constructed by adding a constant value to the previous term to get the next term. This constant value is known as the common difference, and is represented with the letter D. You can find the common difference, D, by taking a term and subtracting the previous term. So in the following example, we have 5, -6, -17, and -28. To find the common difference, D, we would take a term and subtract the previous term from it. So any of these will do. I'm going to take -6, and I'm going to subtract the previous term, 5. And we get -11. So the difference in this sequence is -11. You have to add -11 to move from one term to the next, or to generate the next term. 5 plus -11, -6, -6 plus -11, -17, and etc. Now, if you were to graph these points, 5, -6, -17, -28, against their term number, so this would be the first term graphed at 5, the second term at -6, then this would create a line, okay? Or it would look like a line. The shape would be a line. Arithmetic sequences are closely related to linear functions. When you're talking about a line, the common difference is referred to as the slope. The other type of sequence that we are going to see is geometric. A geometric sequence is constructed by multiplying a non-zero constant by the previous term. And this non-zero constant that you're multiplying by is referred to as the common ratio. You can find the common ratio by taking a term and dividing it by the previous term. So in our example here, we have 2, 6, 18, 54. If I want to know the common ratio here, R, then I can take a term, any term, so I'll take 6, and I'll divide it by the previous term, which is 2. So the ratio here is 3. The non-zero constant that I'm multiplying by to generate this sequence is 3. And you can clearly see that 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54, etc. A geometric sequence is closely related to an exponential function, okay? Because exponential functions grow very quickly and they have a common factor, but with geometric sequences, they have a common ratio. Very similar, closely related. We have a couple examples. We want to determine whether each sequence is arithmetic, geometric, or neither. If it's arithmetic, we want to find the common difference that generates the sequence. If it's geometric, we want to find the common ratio that generates the sequence. So we look at number 1, and we can see that -19 plus 7 is -12, -12 plus 7 is -5, -5 plus 7 is 2, and etc. So this is arithmetic. The common difference here is 7, and you can calculate that common difference by taking a term and subtracting the previous term. So for instance, I can do d is equal to, I can take a term, negative 12, and I can subtract the previous term, negative 19, and I will get 7, which is my common difference. Next, 27, 9, 3, and 1. Well, it kind of looks like we are dividing by 3 each time, but a geometric sequence is supposed to be multiplying. Well, this is geometric. The only difference, we have to express that division as multiplication. The common ratio is going to be one term divided by the previous term. So that would be 9 divided by 27. If I simplify this, this simplifies to 1 over 3. And that makes sense. Division by 3 and multiplication by 1/3 are equivalent. The common ratio here is 1/3. Okay, 27 times a third is 9. A third of 9 is 3. A third of 3 is 1, and etc. Next, we have negative 12, negative 16, negative 20, negative 24, and negative 28. We can see that each time we are adding negative 4. So we're arithmetic, and we can determine that common difference by subtracting one term, or by taking one term and subtracting the previous term. So we could do negative 16, and we could subtract negative 12, which would give us, of course, negative 4. So our common difference is negative 4. Next is negative 9, negative 3, 0, 3, and 9. It starts to look arithmetic, okay? We're adding 6. We're adding 6 to go from 3 to 9. The only problem is that to go from negative 3 to 0 and 0 to 3, we have to add 3. Well, this is not consistent, all right? So it cannot be arithmetic because this is not consistent. It can't be geometric either because how are you going to get 0? You would have to multiply by 0. Well, that would mean that the entire sequence would have to be 0. So that's not okay either. So this is not going to be either type of sequence. That doesn't mean that it's not a sequence. It very well may be, but it's definitely not arithmetic or geometric. It doesn't have a common difference, and it doesn't have a common ratio. Number 5, consider the arithmetic sequence 18, 14, 10, etc. Find the next 4 terms in the sequence. Well, I can tell if I take a term and subtract a previous term, I'll get negative 4. So I know that I'm adding negative 4 each time here to go down to the next term. So 10 plus negative 4 is 6. 6 plus negative 4 is 2. 2 plus negative 4 is negative 2. And negative 2 plus negative 4 is negative 6. So those would be the next 4 terms of my sequence. Number 6, consider the geometric sequence 1, 4, 16, 64, etc. Well, it's geometric, which means that I have a common ratio. And I can find that common ratio by dividing one term by the previous term. So 4 divided by 1, which is 4. That means I'm multiplying by 4 to go from one term to the next. So if I want the next term, I'll multiply 64 by 4, which would give me 256. If I want the next term, I would multiply that by 4, gives me 1024. The next term, multiply that by 4, which is 4096. And the next term, multiply that by 4, which is 16,384. And I'm going to turn these into semicolons so that I can differentiate the terms with this comma here. All right, here are the homework problems for this topic.